Okay, so this is pretty insane now, something unconventional. Now, I'm using about 0.4 of a watt, under a half a watt, like 0.4, 40% of a watt on a resonant coil, which is AC is going through this in series. I got like 12 LEDs. It's averagely bright. Yeah, not as bright as it goes. But anyway, out of there into a bridge rectifier. This goes into a 12 volt battery. So I'm actually pumping, 100 some odd volts into here. 180 volts or something like that into here. And out the negative goes into the negative of the bridge rectifier. Now, with battery, whatever is over the nominal voltage comes back out the other side, the voltage. So the voltage coming out of here is still higher than a positive terminal. So what does that mean? Something very unconventional. Now this is on 1.5 milliamp. It's not really charging that much. But anyway, just for demonstration. This wire goes to the positive terminal. This is a jumper. This is the negative terminal. Now, under any other circumstance, I short this. I put the jumper from negative to positive. The positive goes into the negative and drains the battery really quick. Right? And it heats up horribly. But I'm going to do it. Watch what happens. Remember, 1.5. I clip this. Shorted. I got the battery shorted. Now look, 1.7. Shorting the battery terminals makes the charging amperage go higher because the energy coming out of here is higher voltage than the input still, because we're charging with such high voltage that you could jump the two leads, the two batteries, and take the out, so it's charging in, coming out, and take the out because it's still higher than the in, and go back in with it. And the amps, it didn't go to negative, it's still on positive. I'll take it off and you'll see. It's still on positive, and the charging amps go up. It'll go down to the 15, 1.5 range. It'll slowly work its way down there. The charging amps go up when you short the battery terminals. Now you got to be careful because this has to be hooked up first into the positive and out into the negative, so it has the completed circuit. Then once that's flowing, you could connect the two terminals together to jump your charging voltage by taking the negative return, which is higher than a positive input still, and pumping it back in by shorting the battery terminals. Phenomenal. Yeah, so this is going to creep down until it's, and the whole time while we're doing this, we're also powering this light in series. I want to get more of these or something else and see how many things I could put in series on the way, because this obviously works good in series, this light. And we don't have much voltage drop because there's no amperage. Amperage is in the millivolts coming out of this thing, but the voltage is super high. So if I could get like 5 or 6 of these lights lit with this voltage without dropping much, now we're talking some interesting possibilities. But anyway, I just found it extremely interesting that we could short a battery terminal with a real high voltage, and a charging amperage will go up when it's shorted, down when it's not shorted, because the voltage coming out of the negative again is higher than the positive terminal of the battery. Quite fascinating.